Okay, so in this video we are going to be talking about the properties of the natural logarithm function, and eventually in class we will be differentiating natural logs using the properties, but for this prep quiz I want to focus more just on remembering the properties of logarithms and natural logs that hopefully you'll remember from last year. Okay, so the main properties we're going to be talking about are these four properties. When you take the natural log of two numbers multiplied together, you can rewrite that as the natural log of x plus the natural log of y. You can split it up into its own two separate logarithms. Also, this one, hopefully this one looks familiar, natural log of 1 over x. That's the same thing as saying natural log of x to the negative 1. And hopefully you remember from the power rule, whenever you take the log or the natural log of a term with an exponent, that exponent can become the coefficient. It can be the coefficient or it can be the exponent. So that is the same thing as saying negative 1 natural log x. So that's where that comes from. Anytime you have, just like in this property where you have two terms multiplied inside a logarithm, if you have two terms divided inside a logarithm, you can subtract them. So essentially any number that's in the denominator will be negative, any number that's in the numerator will be positive. And then lastly, this is the same property as this. Whenever you take the log of a term with an exponent, that exponent can also be a coefficient. So hopefully this is all familiar. This is nothing new, but we're just going to do a little practice with these properties now. So for example, if you're asked to write 5 natural log x minus 1/2 natural log y plus 3 natural log z as a single logarithm, your first step is always to write the coefficients as powers. You want to get rid of those coefficients because those coefficients are kind of in the way right now. So remember, 5 natural log x is the same thing as writing natural log x to the 5th. And then this is the same thing as saying minus natural log y to the 1/2 plus natural log z cubed. Once you get rid of the coefficients, now what we can do is combine using the property, the multiplication division property, where everything that is positive is going to go in the numerator. Every term that is negative goes in the denominator. So now we can write this as natural log, all in one natural log. We're going to have x to the 5th in the numerator and z cubed in the numerator, because those are both positive, but our denominator is going to be y to the 1/2, which is the same thing as saying natural log x to the 5th z cubed over the square root of y. Remember, whenever you have separate logs added and subtracted, the positive logarithms go in the numerator, the negative logarithms go in the denominator. Okay, so this brings us to a property like this, or a problem like this. So this is a property that wasn't given on that first slide, but hopefully you'll recognize this property. It says whenever you have a power such as e raised to the log and the base of the exponent is the same as the base of the log that it's raised to, then you can simplify e to the log base e of x as x. So whenever these two values are the same, it simplifies to be whatever you're taking the log of. So in this case, so that means, remember, log base e is the same thing as natural log. So e to the natural log of x is going to be x. Anytime you see e raised to a natural log, you know that natural log, the base of natural log is e. And so you can simplify it to be whatever it's equal to. So in this problem, you see we've got e raised to natural log, so we're going to hopefully simplify it down to where we can use this property. So to be able to use this property, what I'd like to do first is try to simplify the exponent here. Natural log z squared plus 3 natural log x. Let's use our properties here. First, let's use the power rule and make this coefficient a power. Okay, so we can rewrite that 3 as natural log x cubed. So now we can use the product rule here, and the natural log of z squared plus the natural log of x cubed is going to be the natural log of z squared times x cubed. So now we've simplified that down. So now let's rewrite this as e to the natural log z squared x cubed. And remember, e to the natural log of x is equal to x. So we could rewrite this as e to the log base e of z squared x cubed. And do you see, since these powers, or the base of the exponent and the base of the log match, so your answer is going to be z squared x cubed. So that's how these properties work to your advantage. And then lastly, if you're given an equation and you're asked to solve an equation for x, what we have to do again is use our properties to try to solve for x here. So looking at this equation, do you see we have a natural log minus a natural log? So we can use the quotient rule here. We can say the natural log of x plus 5 divided by x minus 3, again because this one is negative, so that goes in the denominator, equals 1. So now to solve a logarithmic equation, hopefully you remember this, we can rewrite natural log as log base e of x plus 5 over x minus 3 equals 1. And remember, converting from logarithmic to exponential, if you have log base b of x equals y, the base of the log is the base of the exponent, and then you take y, b to the y, is equal to x. So these two, so the x goes over here, the y goes over here. So that's what we're going to do here. We're going to now convert this logarithm to exponential form. So we're going to say the base of the log is the base of the exponent. So e to the 1 equals x plus 5 over x minus 3. And now what we need to do is solve for x. So if we multiply both sides by x minus 3, we get e x minus 3 equals x plus 5. And we need to get x by itself, so let's distribute our e, and we get xe minus 3e equals x plus 5. And now if we want to get everything with x in it to one side and everything without x to the other side, we could say xe minus x equals 3e plus 5. We just moved everything with x in it to the left side. Now that we have everything with x in it on the left, we can factor the x out. And we're left with e minus 1 equals 3e plus 5. And lastly, our goal was to get x by itself. So we divide both sides by e minus 1. And so we're left with x equals 3e plus 5 divided by e minus 1. And remember, e is not a variable. E is approximately equal to 2.71828, so on and so forth. So that's perfectly fine. Remember, you got to remember that e is a number in itself. So this is an actual constant. It's a numerical value. I'm not as concerned with what that number is. This is the exact value. You could plug this into your calculator to get a decimal approximation, but this is the most exact value you're going to get. So hopefully working through these problems will help you with the quiz. I hope that helps.